Hello, applied calculus students. Got to speak a little bit louder here. I'm looking at sections 4.5 and 4.6 on optimization, which is finding the maximums and minimums of application problems. So there's a worksheet that you can download. And the first one is a company manufactures and sells X smartphones per week. The weekly price demand, and I'm just calling this a demand function, doesn't have to be price, and cost equations are, so here's your demand function, P equals 500 minus 0.5x, and the cost is 20,000 plus 135x. Even in a cost function, you can see that this is the fixed cost and that's the variable cost. Let's not forget about all of that. What is the maximum weekly profit? How much should the company charge for the phones? And how many phones should be produced to realize the maximum weekly profit? What is the maximum weekly profit? So the idea here is to maximize. We're looking for a maximum. That's an optimization. So maximum profit. So in order to look at the maximum profit, we need a profit function. And we know from our experience that profit is revenue minus cost. So we need a revenue function. So I come over here and I don't have one, but I have a price function or demand function, and I know my revenue is X times P. And when I multiply this function P by X, I get 500X minus 0.5X squared, and I think I've written it just with the X squared term first. Old habits die hard. So we've got negative 0.5X squared plus 500X is our revenue function. So now I'm going to take my revenue minus my cost. So here's revenue minus cost. Simplify. You have to distribute the minus. You've done this a few times. And you end up with this parabola or quadratic equation. And to find a maximum, we take the derivative and set it equal to 0. And I'm getting the critical number. You can do this. The 2 down in front. That becomes 365. Bring that over. Divide by negative 1. And you remember that your units are smartphones because we're talking about X. X is about smartphones. Now the directions say what is the maximum weekly profit. So we're looking for maximum profit. How much should the company charge for the phones? So that's the price. And how many phones should be produced to realize the maximum profit? And what is the profit? So lots of questions here. So far I have 365 phones are going to give me my maximum profit. To get the profit, you plug it into your profit function, this 365. So I went back up here, plugged it into here, squared it, added that, and I got 46,612.50. You can always pause this and see if you do get $46,612.50. And then for the price, little p, I'm going back to my little p and putting 365 in for X. I didn't show that. I just showed the results because showing the work here is below the level of this class. You're at a point where you can just plug in and get the answer, plug in and get the answer. The important stuff right now that I want you to show is your derivative and setting your derivative equal to 0. All right, so the stuff I'm showing should be shown, and then this, you just get an answer. And now the meaning, I wrote to maximize profit of $46,612.50, 365 smartphones should be sold at a price of $317.50 per phone. All right, that is 1A. Now let's go ahead and look at 1B. 1B says, if the government decides to tax the company $5 for each phone it produces, how much should the company charge for the phones, and how will this change the maximum weekly profit? Well, if they're going to tack on a $5 per phone tax, we're going to put this into the cost function. That's what it costs us. So we first had the 135x plus 20,000. That was given. I wrote it in a different. I put the 135x plus 20,000. And now I'm going to add this tax on it, and it's per phone, so it's 5x. Don't just put plus 5. It's $5 per phone. So that gets absorbed into this term. It's 140x plus 20,000. And now we do the same thing we did before. Find our profit function, revenue minus, now the cost function's a little bit different with the 140 now. Distribute, and you get 0.5x squared plus 360x minus 20,000. Take the derivative, set it equal to 0. You get 360 smartphones. One tip is you should never get a negative value here. You can't have a negative number. If you ever get a negative number here, you've made a sign error. So we get 360 smartphones, and I plug that into my profit function, and I get 44,800. Plug it into my price function, I get $320. And my conclusion is to maximize profit of $44,800, 360 smartphones should be sold at a price of $320 per phone. Now, you can write this in 3 sentences. I'm sort of having a good day and writing my sentences, so I just wrote it as 1 sentence. All right, I'll be back for number 2.